This video is about arrays in Matlab. This is the first of 3 videos about arrays in Matlab. The topics we will discuss are what is an array, how do we create constant arrays in Matlab, how do we create arrays in both 1 and 2 dimensions, and then finally how do we use these arrays inside functions. First, let's discuss what an array is. Essentially, an array is a collection of values all stored under the same single name of a variable. Think of it like an Excel file or Excel worksheet, where one file, one name, has many values contained inside. An array can be one-dimensional, like a single column or a single row of data, or it can be two-dimensional, like an entire worksheet. Again, all of these values sharing the same variable name or file name if you're thinking of an Excel worksheet. Let's see how we create arrays inside Matlab. This video will just look at constant arrays, not variables. To create an array in Matlab, you start off with a square bracket, and then if you want to place elements all in a single row, you can separate different values with a space character such as 0, 5, -2, 3.14, ending the array with a closed bracket. We have now created this constant array with these 4 values shown here. If you prefer, you can use commas instead of spaces. They mean exactly the same thing. Here's another array, 1, 10, 5, -1. And so again, we've created a 4-element row array, so they're arranged all in one row. If you prefer to have a column array, that can make a difference, especially if you're doing linear algebra or matrix work. Then you separate the columns using semicolons. So if we want to create an array which is a single column with maybe these 3 elements, then use semicolons, and now we've created a single column one-dimensional array instead of row one-dimensional array. Another way to create a column is with the apostrophe. So I've used commas here, which would normally make this a row array, but if we add an apostrophe to the end of an array or matrix, that does the transpose, which means change rows to columns and change columns to rows. Okay, some other ways that you can create one-dimensional arrays are using the colon operator. So 1:5 means create the array from 1 to 5, separating each element by exactly 1. So this text here, 1:5, means the exact same thing as the row array with elements 1, 2, 3, 4, and 5. If you don't want to have a spacing of exactly 1 between each element, you can use 3 numbers with colons. So 30, 10, 60 is the exact same array as 30, 40, 50, 60, as shown here. Again, the colon command always creates a row array by default. Okay, things can even be non-integer values using this. So if we want to create the array from 6.5, counting down by 2.5 until we get to -1, then the colon operator can operate using whatever interval you place in this middle value between the 2 colons. So here it starts at 6.5, counts down by 2.5 until you get to this last value of -1. Sometimes you know, instead of the spacing between each element, you know how many total elements you want between an endpoint, a beginning point and an end point. So there's a function for that called linspace, meaning create a one-dimensional row array where each element is linearly spaced. So here you indicate the beginning, let's say 0, the ending, let's say 1, and then not the interval between them, but how many data points you want. So if you want 4 values between 0 and 1, then this gives you a row array with 4 values starting at 0, ending at 1. Or if you wanted to go from -2 to +2 and you wanted 5 elements, then here's that array. If you want things that are logarithmically spaced instead of linearly spaced, there is a log space, just like linspace. And log space works slightly differently in that the first value is 10 to the value, so this would start at 10 to the -1 or 0.1, and this would go to 10 to the +1 value or 10, and if we want 5 values logarithmically spaced, then this gives us a row array starting at 10 to the -1, ending at 10 to the +1, and spacing logarithmically 5 values in total. If you want to create two-dimensional arrays, then you can use both commas or spaces to separate elements within a row and semicolons to start a new row. So here is the row array, which is 3 elements in each row. Here's our first row, 5, 24, 12, a semicolon starting the next row. Here's the second row, now a third row, and let's do a fourth row. Again, I'm using commas, actually a comma and a space to separate elements within each row. You can use a comma, you can use a space, or you can use both. So now I've created this two-dimensional array separating each row with a semicolon, separating elements within each row using a comma. Notice you can't do something like this. Let's put 1, 2, and 3 in the first row and try to put 1 and 2 in the next row. It's going to tell you that there's an error. You have to have the same number of elements in every row, the same number of elements in every column. Okay, and you can combine things we used before, such as colon operators. Let's make the first row of this two-dimensional array 1, 2, 3, 4, 5. The second row of this two-dimensional array, the 5 elements spanning 0 to 8, let's say. And the third element of this row, 5 counting down by 1 to 1. Okay, and we can create this array by combining these one-dimensional arrays, all of them 5 elements long, into this two-dimensional array using semicolons. Last thing I want to discuss in this video is using array inside of functions. So let's look at this array, the array that goes from 0 to 2 pi, and let's have 5 elements. So here's an array that goes from 0 to 2 pi with 5 total values. You can add values to every element in an array just using the addition symbol. So when I hit enter, you'll see, that these 5 elements are the same as what we had before, just adding the value 1 to each of them. You can send elements to functions like sign, so I'm going to copy and paste this time. And now we have the sign of each of these 5 values just by sending that entire array to the sign function. We can do the same thing with cosine. Now we have the cosine of those 5 values. And you can even do things like see which elements are less than pi. And you can see a 1 comes out for the 2 elements that were less than pi, and a 0 comes out for the elements that are greater than or equal to pi.